This is question 16 from the 2012 exam. I'm going to assume that you're familiar enough with the simplex algorithm that I don't have to go through every small little step. If you need further assistance with the simplex algorithm, refer to some of the earlier exam questions. What we need to do is understand what the linear programming problem we're trying to solve is for this question. The first thing we'll do is notice that not all of our values in the payoff matrix are non-negative. We take the most negative entry, which in this case is -4, and add the absolute value to every value in the table. In other words, we add 4 to each entry. This means now that we're maximizing W equal to U1 plus U2 subject to 2 plus 4 is 6, 1 plus 4 is 5, -4 plus 4 is 0, and 3 plus 4 is 7, times U1, U2 less than or equal to 1, 1. Now that we have our problem set up, we can write down our initial tableau. U1 and U2 for our decision variables, and because we have two constraints, we have x1 and x2 for our slack variables. Our slack variables again, x1 and x2, go here. We put in our payoff matrix in its adjusted form, fill in the rest of the table in the usual way. We're maximizing U1 plus U2, so we have -1, -1, 0, 0, 0. Now we're going to perform the simplex algorithm in the usual way. We find the most negative value in the bottom row. In this case, we have two choices. I'm just going to choose U1 as our entering basic variable. And then we find the smallest ratio of these values in the right-hand column with the values of the column that we're currently looking at under the condition that they're positive. In this case, there's only one positive variable in this column, so we automatically choose this as our pivot point. So U1 is our entering basic variable and x1 is our departing variable. x2 stays the same. We want to turn this 6 into a 1, so we divide that entire row by 6. 6 divided by 1 is 1, 5 divided by 6, 1 divided by 6, 0 divided by 6 is 0, and 1 divided by 6. And we want to make everything else in that same column a 0. We already have a 0 here, so we can leave this row the same. For our bottom row, we want to add one copy of the new U1 row to make this -1 into a 0. So -1 plus 1 is 0, -1 plus 5 on 6 is -1 on 6, 0 plus 1 on 6 is 1 on 6, 0 plus 0 is 0, and 0 plus 1 on 6 is 1 on 6. And now we repeat the process. This time we only have one negative value in our bottom row, so this means that our entering basic variable is U2. Now let's look at the values of the right-hand column divided by the values in the column for U2. 1 on 6 divided by 5 on 6 is 1 on 5, and 1 on 7 is just 1 on 7. 1 on 7 is smaller than 1 on 5, so this value becomes our pivot point. Now we want to turn that 7 into a 1. So our entering basic variable is U2, and we divide this row by 7 to get our new values. 0 divided by 7 is 0, 7 divided by 7 is 1, 0, 1 divided by 7, and 1 divided by 7. We want our U1 row to have a 0 in this entry. We currently have 5 on 6 in that row, so we subtract 5 on 6 times the U2 row from the above column. So 1, which is here, minus 5 on 6 times 0 is still 1. 5 on 6 minus 5 on 6 times 1 is 0. We have 1 on 6 minus 5 on 6 times 0, which is 1 on 6. 0 minus 5 on 6 times 1 on 7. Let's calculate that off to the side. 0 minus 5 on 6 times 1 on 7 is 0 minus 5 on 42, which is minus 5 on 42, which is what we get in that row. Finally, we find for this column, we have 1 on 6 minus 5 on 6 times 1 on 7, which is 7 on 42 minus 5 on 42, which is 2 on 42, or 1 on 21. Finally, we want our bottom row to have a 0 in this entry as well, so we'll add 1 on 6 times the row for U2 to the bottom row. 1 on 6 times 0 is 0, plus 0 is 0. 1 on 6 times 1 plus minus 1 on 6 is 0. 1 on 6 plus 1 on 6 times 0 is 1 on 6. 0 plus 1 on 6 times 1 on 7. Let's calculate that down here. 0 plus 1 on 6 times 1 on 7 is 1 on 42. And so we have 1 on 42 in this row. And down here, for this entry, we have 1 on 6 plus 1 on 6 times 1/7. And I'll calculate that up here. That is equal to 7 on 42 plus 1 on 42, which is 4 on 21. Since there's no negative values in the bottom row, that means that the simplex algorithm terminates. So we can extract all the information we need for the rest of the question from the final tableau. Let me relocate the final tableau over here. Now for part A, we want to find the optimal mixed strategy for player 1. To do that, we need to know the values of U1 and U2. U1 is given by the value in the right-hand column in the row where U1 appears. So U1 is 1 on 21. Similarly, U2 is 1 on 7. In order to determine the strategy, we also need to know what the value of U1 plus U2 is. That's 1 on 21 plus 1 on 7, which is 1 on 21 plus 3 on 21, which is 4 on 21. So now we can say that the probability that player 1 should make move 1 is equal to U1 divided by U1 plus U2, which is 1 on 21 divided by 4 on 21, which is equal to 1 on 4. The probability that player 1 should make move 2 is U2 plus U1 plus U2, divided by U1 plus U2, which is 1 on 7 divided by 4 on 21, which is 1 on 7 times 21 on 4, which is 3 on 4. So we conclude, the mixed strategy for player 1 is P1, P2 equals 1 on 4, 3 on 4. Now, for part B, we can also use the table to get this information. We take the reciprocal of the bottom right-hand value and subtract the value that we added to every entry at the start. So for part B, the expected payoff is the reciprocal of the bottom right-hand corner is 21 on 4, and we subtract the value that we added at the start. So that's equal to 21 on 4 minus 16 on 4, or 5 on 4. So the expected payoff for player 1 is 5 on 4. So that allows us to answer part C. Remember that this is a zero-sum game. So whatever player 1 wins, player 2 loses. And since player 1 is expected to win a positive amount, that means player 2 is expected to win a negative amount. And so we can conclude that the game favors player 1. And we're done.